In this video, we'll be talking about properties of definite integrals. Just like limits have mathematical properties, definite integrals do too. Recall that a definite integral is represented by the integral from a to b of f of x dx, where a is less than b. The following properties can now be used to help us compute definite integrals. The first is if the definite integral has equal bounds, then the value of that definite integral is equal to 0. If the bounds are reversed, so if the greater number is really in the spot for the lower bound and vice versa, then we are going to reverse the bounds, put them back so that the lower bound is the lower number, but we basically put a negative in front to show that we are inverting. If we are multiplying by a constant, we can pull that constant out in front of the integral. A very common one on a lot of questions is this one about additive intervals. So notice here for this definite integral property, it says that a is less than c, which is less than b. Okay, so that basically means c is in the middle of a and b. So this says that the integral from a to b is equal to the integral from a to c and from b to c. If you think about that just like in terms of, we'll use a number line with these letters for a minute. So if I have a and b, and then c is somewhere in the middle, you can see that if I add the space from a to c and c to b together, I get the whole entire thing, a to b. All right, for the addition rule, if we are integrating two functions that are being added together, we can separate that definite integral and evaluate each function's antiderivative separately, and the same idea for subtraction. So let's look at some practice questions using those properties. So it says, given that the integral from -3 to -1 of f of x dx is 3, the integral from -1 to 2 of f of x dx is -6, and then from -3 to -1 of g of x dx is equal to 10, we're going to find each of the following. All right, let's take a look at a. In a, I notice that the bounds are inverted. So -3 is the lower number here, so that really should be the lower bound. So using our reverse bound property from the previous slide, I'm going to pull a negative out front, and I'm going to evaluate the definite integral from -3 to -1 of g of x dx. And if I slide over here just to my facts, I can see that that is equal to 10. So since we have the negative out front, this is equal to -10. For b, we're evaluating the definite integral from -3 to -3. When the bounds are equal, the value of the definite integral is 0. That's because definite integrals represent area under the curve, and we are not giving any width to that area. If we were imagining rectangles, for instance, when we talked about Riemann sums, the width or the change in x is 0, therefore the area has to be 0. All right, for c, the upper bound is 2, the lower bound is -3. When I look at my facts up here and these little clues that the problem has given us, I don't have one that looks exactly like that, but I see that I could add some pieces together to get something equivalent. So this is equal to the integral from -3 to -1 f of x dx plus the integral from -1 to +2 f of x dx. This is our using our property of the additive intervals from the previous slide. Well, we know that this is equal to 3, this is equal to -6, so we get -3 as our answer here. All right, for d, the integral from -3 to -1 of f of x minus g of x. So using our subtraction rule, I could rewrite this. It's almost in a way like I'm using the distributive property by distributing the integral across each of these functions. So now I'm going to look at my clues at the top. The integral from -3 to -1 of f of x is 3. With the same bounds, but for g of x, that was 10. So when I subtract them, I get -7. All right, for e, we're looking for the absolute value of the integral from -1 to 2 of f of x dx. Well, we know from our clues that this is equal to -6. Absolute value of -6 is +6. All right, and our last one here combines a couple of rules. We see that we have two functions being added together, so we're going to use the addition rule, but we are also going to use the multiplication of a constant rule. So I'm going to rewrite this initial problem by pulling the 2 out in front, and then kind of like the problem above it, distributing the integral symbol across the two functions. Now I'm going to plug in any values I know. So I know that all of this is equal to 3. I know all of this is equal to 10. So 2 times 3 plus 10 gives me 16 as our value for f. All right, just a couple more questions here to look at. Number 2 says if f of x is an even function and the integral from 0 to 5 of f of x dx is 8, we're going to find the integral from negative 5 to 5 of f of x dx. So let's put a couple of pieces together here. If we don't remember, an even function means that it is symmetric over the y-axis. Okay, so that's going to be a key piece of information here. And I also realized that I'm going to have to add some pieces in here. So it would be very helpful if we knew the integral from negative 5 to 0 of f of x dx. Here's why that would be useful for us to know. If we're looking for the integral from negative 5 to positive 5, using the additive interval rule from the previous page, we could say, well, that's equivalent to the integral from negative 5 to 0 added to the integral from 0 to 5. Okay, we know that basically this is equal to 8. Okay, the problem gives us that piece of information. So if we could figure out the integral from negative 5 to 0, we could figure out that total value that the question's asking us for. Well, if it's symmetric over the y-axis, that means basically whatever's happening to the right of the y-axis is also happening on the left. So let's take a look at what that might appear to look like here. If I have a graph, let's say I was just drawing an upside down parabola here, kind of a quadratic function. Remember, a definite integral represents the area under a curve. So we know from 0 to 5 that that area is 8. Well, if this is symmetric, that would mean that from negative 5 to 0, that area is also 8. So I'm going to go in here and I'm going to say, well, this we know is 8. This we know is 8. So therefore, our final answer for number 2 would have to be 16. Let's see how that relates to number 3, though, because number 3 is a very similar question. However, it tells us that f of x is an odd function. So if we don't remember, this means that it's symmetric over the origin. So once again, it would be really helpful if we could determine, well, what's the value of the definite integral from negative 5 to 0 of f of x dx? That would help us be able to find our actual sum. All right, so if I just say I draw a quick picture here of a function that is odd. So I'm just going to draw a simple one. I'm going to draw y equals x. We basically know that from 0 to 5, that the area is 8. Well, knowing that this is symmetric over the origin, that tells me that from negative 5 to 0, that value is negative 8. We're going to have a negative in there since that's below the axis. So this tells me that my final answer to this problem, this is negative 8, my final answer for the definite integral from negative 5 to 5 of f of x dx would really be negative 8 plus 8, which is going to be 0.